Hey everyone, this is me, Bravit Mohapatra, and we all know that data science is the most grooming field in today's century. And to get excel and to get job in that, we all need some projects which would showcase that yeah, we have the knowledge and we have done this project in regard with data science, and the interviewer will be so much happy to take you in. So as per the demand, I have bought a project, and in this project in short, we are going to analyze the TV data. So in this, we are going to use the intermediate Python. We are not going above that, and we will try to analyze and extract meaningful insights from various sources. For this set of project, you will use a combination of data manipulation and visualization to explore television data. In this project, this will be a guided project. I will guide you all the steps in this, and I will also share the link with you, my GitHub link, where you could go and get this project and also showcase it in your CV. So without wasting time, let's get into it. So the first one is like I have divided this project into certain parts, and there will be 10 parts, and this one is the first, and we will slowly proceed into the analyzing part. So I will briefly describe and explain everything to you, which will make it easy for you to understand and really get into it. So the first one is TV halftime shows and the big game. Whether or not you like football, the Super Bowl is a spectacle. This data set is of Super Bowl. It's a kind of a data which you will get almost everywhere in the Kaggle also. So we are going to look into the Super Bowl data, generating insights, game outcomes, viewership, and even halftime shows. In the meantime, let's get into it without wasting the time, and let's make this video a short one so it would be really easy for you to just watch all this video in a single go and then directly get into the code. So in this, what we are going to do is the first thing is what are the most extreme game outcomes? How does the game affect television viewerships? How have viewerships, TV ratings, and ad cost evolved over time? How are the most prolific musicians in terms of halftime show performance? So we are going to do all this thing in this project. So here are the data sets link and everything is there, and I will give you the link also in the description below. So yeah, in the first one, the data set we will use was scrapped and polished from Wikipedia. It is made up of three CSV files, one with game data, one with TV data, and one with halftime musician data for all 52 Super Bowl through 2018. Let's take a look using display and instead of print, since its output is much prettier in Jupyter Notebook. Let's do it. So first of all, as we all know that we got to import the pandas. So through this we will import the pandas, then we will call the CSV files and the data sets present from here. So we will call the Super Bowl, the TV data, the halftime musicians data, and then we will display the same in the sequence like Super Bowl head. And if anybody don't know what is this head method is used for, it is used to showcase the top 4 or top 5 of the whole data set. Suppose if you have a data set where there are more than 10,000 or much bigger amount of data, if we use head there, they will showcase you the top 5. So you can see here the top 5, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, top 5, top 5. So This is the Super Bowl data, this is the TV data, and this is the half musician data. And while you watch this data, just try to understand what this data is trying to say, what is this data is trying to showcase. So before going into the further steps, just watch what are the things this data is showcasing us. So the Super Bowl data is showcasing us the venues, the date when it happened, the city, and which state, how many people attended it, the winner team, winning points, the winner Q1, Q2, coach winner, who was the loser team, losing points, coach loser, combined points, different points. Everything is specified in here. The TV data showcases us the Super Bowl, then the network, like which media partner showed it and how much the average viewers were of them, the total US viewers. Like we are mainly focused on the USA based viewers, rating households, share households, rating 18, 19, 14, share, ad cost. And then last one is here we are having the musicians list and number of songs. So Justin Timberlake played now 11 number of songs, and same for Gold, Lady Gaga, Gold, Coldplay, Beyonce. So moving on to the next, taking note of data set issues. For Super Bowl game data, we can see the dataset appears whole except for missing values in the backup quarterback column. QB winner 2 and QB loser 2. Like you can see here, QB winner 2 and QB, and here is QB loser 2. Here the data is missing. Whenever while you are fetching the data, if there is a missing value, what Panda does is they put NaN, that not available. So what we are going to do is like, now we know that we have missing values there, which makes sense. Give more stating QBs in the Super Bowl. Play the entire game. From the visual inspection of TV and halftime musician data, there is only one missing value displayed. But I've got a hunch there are more. The Super Bowl goes all the way back to 1967. So we have a large amount of data set from 1967 to 2018. There's a lot. So what we are going to do is an inspection of the info. Like it will give us the detailed data about the data set we have of the output for TV and halftime musician shows us that there are multiple columns with null values. So what we are going to do is we're going to use this describe function, which will describe, or in short will give you the summary of TV dataset. So here it is, like when you use describe, and if you are a R language user, like there's also R language. If you are familiar with the data science field, you must be knowing about it. In R language we use summary, but in Python we use describe. So it will give you the count, mean, standard, mean, 25%, 50%, 75%. These are the IQRs, interquartile ratio, and then maximum minimum. So this will give you the whole summary of the TV data. Then summary of TV data this is, and then the summary of musicians, halftime musicians. So you could see from here the summary, then the combined points distribution. See, for the TV data, the following columns have missing values. And we could see, we have seen that the total US viewers rating 1849. You can go through these all the descriptions and everything is mentioned, like what are the specific column is showing us why we need that column, what is the use of that column in our project. You can go through all of this and you will be able to really get into the data set. Being data scientist is not about just programming, it's more about getting into data set and finding and visualizing the information out of it, like what the data want to tell you, that what you need to understand, and then you need to convey through your projects. your visualizations. This is what data science project, data analysis is in short. So now let's start by looking at combined points for each Super Bowl by visualizing the distribution. Let's also pinpoint the Super Bowl with the highest and the lowest scores. Okay, so we need the highest and the lowest scores also. So now what we're going to do is we're going to use matplotlib and set the plotting styles. Okay, and in this we are going to use the histograms. So for importing the matplotlib we need to do this. Then inline we are going to use the cbond functions. Then this is the code for using the histograms on the combined point and the number of super balls. Then we need to display this. So when you will display this, you will get this type of histogram where you can see the values of number of super balls per combined points. And this is the table for the same values. Now, point the difference distribution. Like we need to see that what is the difference, what are the key things we need to understand. So in this we're going to use the histogram again, and then we need to see that difference points, like see, difference points give you the extremist point. Like extremist point is that when you have a particular data set, and that data set there is a particular data which is extreme. Like suppose we are having a data set of age, and there are total 10 we have total 10 values, and suppose in that 10 values 9 values are of like 20, 18, 17, 19, like this only in the range between 17 to 21, and the 10th value is suppose it's beyond far, like it is of 97. So what will happen that when we plot the graph, it will become the extreme point. Like in this portion, you will have the whole of your data, your visualization, and there would be a big gap in between, and then that 97 will come. So this is what the difference we are finding in this. Then, then the next thing is that do blowouts translate to lost viewers? Maybe. See, the vast majority of Super Bowls are close games. Make sense? Yeah. Both teams are likely to be deserving if they have made in this far. The closest game ever was when the Buffalo Bills lost to the New York Giants by 1 point in 1991. It was far away, but such thing happens, and that match was really great and amazing. If you have access, you can go through the YouTube and search for this match. It was amazing. So what happened was that, which was the best remember, was Scott Norwood's lost second missed field goal attempt that went wide right, kicking off four well Super Bowls losers in a row. Poor Scott. The biggest point discrepancy ever was 45 points, where Hall of Fame Joe Montana led the San Francisco 49ers to victory in 1990, 1 year before the closest game ever. So these are the things which do happen, and do they really affect in losing the viewers? So in this we are going to find that. The first we are going to do is join game and TV data, filtering out the SP because it was split over two networks. Okay, so how we do it is like we use pandas pd.merge, then TV Super Bowl, and if greater than one, then Super Bowl on Super Bowl. Okay, On Super Bowl, it's like on the Super Bowl column, we need to do this combination. So now import Seaborn, like we import Seaborn using SNS. It is an allied name. So now create a scatter plot. We are going to use scatter plot this time before we use histogram. Now this time we are going to use scatter plot with a linear regression model fit. Okay. So this is the code you need to write for the using scatter plot. Like in the x-axis, you need to take difference points. In y-axis, you need to take share households, and the data is game TV, which you created, which is a combination of game and TV data. Okay. So now you can see the scatter plot here. Yeah, okay. So this is how you create a scatter plot with linear regression model fit. Okay, now the sixth one is like viewership and the ad industry over time. Like ad industry is very massive and the viewership of this game is hugely in demand. Like it is a big type of game in USA, like IPL in India. That's what Super Bowl is, and USA it matters a lot. Okay, the downward sloping regression line and the 95% confidence interval for that regression suggests that, see, you can see there's a downward regression line. It's not upward, it's downward. Suggests that the bailing on the game if it is blowout is common. Through it, though it matches our intuition, we must take it with a grain of salt because the linear relationship in the data is weak due to our small sample size of 52 games. Like there are massive number of games, but one can't do all, like one can't bring all that data set and then put it into just a laptop. You need big servers, you need big infrastructure for that. So what we did was we took a small combination, like we took a sample size, okay, of 52 games, and then we did the linear relationship on that data. It may be weak, but it suggests that on big perspective, you can see that if its sample size is still in downward linear regression, the whole data would be also in downward linear regression. So that's the benefit of using sample size instead of the whole data. So regardless of the score though, I bet most people stick it out for the halftime show, which is good news for the TV network and advertisers. A 30-second spot costs a pretty $5 million now, but has it always been that way? And how have number of viewers and household ratings trended alongside ad cost? We can find out using line plots that share a Super Bowl x-axis. So, and this what we are going to do is like create a figure with 3 into 1 subplots and activate the top subplots, okay? So we took a subplots 311, then another subplot that points would be like TV Super Bowl, TV average users, color, and then the title would be like average number of US users. As I have mentioned before only that this data is particularly for the US based users because the Super Bowl is mostly famous in USA only. So we took the data of USA only. So activate the middle subplot, okay? So the middle subplot is for household ratings and the bottom subplot is for ad cost and the whole label is for Super Bowl. So when we did the comparison, we would get like this. This is the line graph. Okay, uh, we can see like viewers increased before ad cost did. Maybe the network weren't very data savvy and were slow to react. Makes sense exactly. Okay, so we can see that it increased over time period. The cost, the ad cost, the household ratings, the viewers, everything just raised and is still raising. Okay, so what we're going to do next is like halftime shows weren't always this great. Okay, so we need to find out like does halftime shows really matter or not? So we have like there's a brief data history which is showcasing that in 1992 Approach to Snowman rap performed by children and Elvis impersonator that did magic tricks and didn't even sing one Elvis song. So these are the things that happens. I went down YouTube rabbit hole and it turns out that old ones weren't of today's standards, some offenders. It turns out Michael Jackson's Super Bowl performance, one of the most watched events in America TV history, was when the NFL realized the value of Super Bowl airtime and decided they needed to sign big names acts from then on out. The halftime shows before MJ indeed weren't that impressive, which we can see by filtering out halftime musician data. Okay, so what we did is like we tried to display all halftime musicians for Super Bowl up to and including Super Bowl. So this is what we did. We showcased the halftime musicians of Super Bowl, which were less than or equal to 27. So this is what we got, the number of songs, and you can see that there are still NaN values, not available values, okay, and these are all less than 27. Lot of. So moving on, who has the most halftime show appearance? Okay, so now we need to find us like who has the most show appearance. Like, is it Michael Jackson, Gloria Estefan, or any of your favorites? Let's check out. So what we did is like we count halftime show appearance for each musician and sort them from most to least. Okay, so it's in a like kind of descending order. We sorted them. So what we did was we start counting. We did group by and then sorted the values. Okay, in ascending false, which means in descending order. Okay, then display musician with more than one halftime appearance. So now we have displayed musician of for more than one halftime appearance, and what we got is like the Grambling State University Tiger Marching Band was the one who has the most halftime show appearance in the Super Bowl. Next to them is Up With People and All Hurt, the Human Joke Box, and the furthermore. So now, the next one. Who performed the most songs in a halftime show? Now we know that this band has the most halftime show appearances. Now, who performed the most songs in a halftime show? For this, we need what? We need now the name of the musicians. Okay, so we need musicians data. Okay, so let's filter out. So what we did was we filtering out the musician with the word marching in them and the word spirit, a common naming convention for marching band and spirit of something. Then we will filter for Super Bowl after Super Bowl XX to address the missing data issue. Then let's see who has the most number of songs. So as mentioned, first we filter out the marching bands. Okay, we filter out the marching bands contains which contains marching, and then the marching number of marching bands which contains spirit. Then we plot a histogram. Okay, for most songs like for maximum. Okay, for maximum number of songs in values. Then we took the X label as number of songs per halftime show performance to the Y level number of musicians. And we got to know that, yeah, and when you see this, you can see that this portion is of Justin Timberlake. So it was Justin Timberlake who has performed the maximum time, and the number of songs were 11. So now the conclusion. So most non-band musicians do 1 to 3 songs per halftime show. It is important to note that the duration of the halftime show is fixed, roughly 12 minutes. So songs per performance is more a measure of how many hit songs you have. Justin Timberlake went off in 2018. Wow, 11 songs. Diana Ross comes in second with 10 in her medley in 1996. In this notebook we loaded, cleaned and explored Super Bowl game, television and the halftime show data. We visualized distributions of combined points, point differences and halftime show performance using histograms. We used line plots to see how ad cost increase lagged behind viewership increased, and we discovered that blowouts do appear to lead to a drop in viewers. This year's big game will be here before you know it. So so this data was of 2018, and let's predict that who will win the next Super Bowl. And for that we did Patriots, New England Patriots, Rams, Los Angeles Rams. Then Super Bowl winner Rams is equal to Rams, and then we printed it. So the winner of Super Bowl LI will be the Los Angeles Rams. Thank you guys. So I will share the whole page in my GitHub account and share the link in the description. Also, I will provide you the data set. So just do one thing is that go through the link, download this notebook, and then go through this program. Everything is explained briefly. All you need to do is take some time and give this thing some time, and it would be really beneficial for you. And we'll definitely come with new projects soon. Till then, bye bye.